Okay, so question 11, 11.1. Each of the digits, we have 1, we have 2, 3, 4, and 7, are written on a separate card. The cards are then placed next to each other to create a 6-digit symbol. So, yes, 6-digit number. 11.1.1. How many numbers start and end with the same digit? How many numbers start? So we're having, let me just write it here. We're having 1, 1, 2, 3, 4, and 7. So these are the numbers that we have. And we are asked how many numbers start and end with this. And we are asked how many numbers start and end with the same number. So this is what we have here. 1, 1, 2, 3, 4, and 7. And we are asked how many numbers start and end with the same digit. And we are told that these numbers, let's say they are placed on a card separately, something like this. So let's say, for example, this is 1, this is 1, this is 2, this is 3, this is 4, this is 7. And we are asked how many numbers are placed next to each other having the same digit. And we are asked how many numbers have the same digit from start to end, right? So to solve this problem here, because the question says that we want the number of numbers that start and end with the same digit. So don't confuse same digit with identical digit. So we can simply say, if we say 1, this number here is the same as 1, this number here. If we say this card is the same as this card, right? And we assume that the card of 1 and the other card of 1 are identical. They are identical. You know, when you talk of identical, you think of twins. Because you can have a human body, 2 human bodies, but those bodies are not identical, right? So let's assume that these 2 human bodies, or these 2 cards rather, are identical. So if we assume that they're identical, so meaning that by redrawing these cards here that I drew on top, we're going to say 1, we start with 1, and then in between, it's going to be these numbers here, all these numbers. So it's going to be your 2, your 3, your 4, your 7, and then we're going to end with 1. So we start with the number 1, we end with number 1, and we consider them identical. And then in between is going to be 2, 3, 4, and 7. So what's going to happen is, if we consider the first and last, if we consider this to be identical to this, then it's going to be 1 factorial. It's just simply going to be 1 multiplied by, so what happens in between is going to be different, right? So meaning these cards are different. 2, 3, 4, 7 cards are different from each other. So there are 4. We have 4 cards, right? So meaning it's going to be 4 factorial multiply by the 1 because we consider it to be the same as the other one and they're identical. So you're going to have 1 multiplied by 4 factorial multiplied by 1, which you'll have 4 factorial as your answer, which is going to be 24 ways. So this is how you're going to solve this problem here. Now, 11.1.2 says that find the probability that the number is 1, 1, 2, 3, 4, 7 or 7, 4, 3, 2, 1, 1. So we need to identify the probability of this happening. So if we said, as we said, that the number 1 or the card which has 1 inside and another card which has 1 inside, if you consider them to be identical, this is how you're going to find the probability. We're going to say the probability of these two numbers happening is going to be equals to the factorial of 6. Why am I saying the factorial of 6? You're going to count your digits. So it's going to be 1, 1, which is 2, 3, 4, 5, 6. So all these numbers combined, they are actually 6. So that's why you're going to say 6 factorial divided by 2 factorial. So the 2 factorial is for these two cards here, which we consider to be identical, right? So you're going to get your answer here, which is 360. And then the probability will be equals to, because these two was for identical cards. Now let's find the probability of the non-identical cards. Okay, so because we're looking at identical cards, we're going to say how many identical cards do we have? We have 2 divided by the 360, which will give us 1 over 180. So this is the probability of these two happening here. Now, 11.2 says that n people, 1, 2, 3, 4, 5, 6, up to n, are arranged randomly in a line. So let's say you have people, you have this person here smiling, another person here maybe frowning, another person here. So they are arranged in a line, they're standing on a queue, whatever, randomly. So find the number of ways in terms of n such that person 1 and person 2 are standing next to each other. So if we consider this to be person 1 and we consider this to be person 2, we must find the number of ways in which these people are going to be standing next to each other. So how do we identify that? So what we can do is to find the number of ways in which they are standing next to each other. We're going to use 2 factorial because we're looking at person 1 and person 2. So that's 2 factorial. And the total number of people, it's n, right? Because when you say n plus 1, you are going to the next person, right? It's next. Like if you think of it in terms of your sequence and series, right? If you say S is equal, so if you say n minus 1, you are basically talking of the previous person, So this is the next person, this is the previous person. So we're going to take this n minus 1, meaning that we are going backwards, so meaning the next person. So this is the forward person and we say minus 1 because you consider the previous person. So the answer here is going to be 2 factorial into n minus 1 factorial. So that is the solution, the number of ways in which person 1 and person 2 will be standing next to each other. Thank you so much for watching. If you have any questions, suggestions, or comments, please write them in the comments section below. Don't forget to subscribe to the channel for more videos.